Hi, I'm Venu, CEO of Manjeera Digital Systems, a startup based in Hyderabad, India. When Intel approached us to collaborate on developing a hardware accelerator for AI-based speech processing algorithms, we saw a challenging opportunity in it. Because speech AI belongs to a complex category of workloads which are both memory and compute intensive, and the latencies have to be very low. FPGAs with their wide data path are ideal candidates for such workloads. However, AI is a rapidly evolving field with new topologies and compute functions necessitating the development of new RTL blocks frequently. Building multiple RTLs and optimizing them for best performance is time consuming and resource intensive. A common approach is to build a superset of all RTL functions and choose them as needed for each algorithm. A disadvantage of this approach is that all RTL blocks are not always used, leading to inefficient use of FPGA resources and hence reduced performance. And if a new topology has a new function that's not in RTL already, back to redoing the RTL. So the challenge is to achieve high performance of hardware data paths while retaining the flexibility of software. This is where we saw an opportunity because our IP, Universal Multifunction Accelerator or EMA, exactly fits this requirement. EMA is a patented data path architecture that performs in memory computing. So we combined the software programmable EMA with high performance Intel FPGAs to develop a general purpose programmable AI accelerator called Programmable Inference Engine or PI. The EMA based PI is highly optimized RTL that can be deployed on Statix 10 and Area 10 FPGAs. PI offers a simple C programmable data path, which means you can accelerate any function without RTL change. Soon you can run any AI topology on PI using its OpenVINO plugin or plugins of other frameworks. Any new function can be easily added through just software porting. Our tests show that PI delivers industry-leading performance for speech recognition workloads. Mozilla DeepSpeech is a large LSTM-based speech recognition algorithm which is highly memory and compute intensive. We ran this workload on PI ported on Statix 10 MX FPGA. The measured latency is up to 4x lower than a leading GPU. You can see PI performing real-time speech transcription using Mozilla DeepSpeech in this demo video.
It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness. It was the season of light, it was the season of darkness. It was the spring of hope, it was the winter of despair. We had everything before us, we had nothing before us.
Extreme low latency provided by PI running on Statix 10 MX FPGA enables customers to deploy highly complex AI algorithms without compromising on the real-time performance. These AI models enable use cases such as voice assistants, cognitive contact centers, and time series analysis, and so on. PI powers real-time performance across all these use cases. Please check out our solution brief for more details on how PI can deliver great performance for your AI workloads. Thank you.